Welcome back, Rustaceans. Get ready to dive deeper into the world of Rust. Today, we're not just talking theory, we're rolling up our sleeves and writing real, exciting Rust code. In this video, you'll dive into a ton of new Rust concepts. Some of them might seem a bit unclear right now, but don't worry, we'll break them down in detail in future videos. The goal today is to finally get our hands dirty with real Rust code, build something fun, and start getting comfortable with Rust's basic syntax and concepts. Alright, Rustaceans, here's the game plan. These are the key steps we're going to implement to bring our guessing game to life. First, we'll generate a random number, because what's a guessing game without a little mystery, right? Next, we'll prompt the user to enter their guess, capture their input, and save it for processing. But we won't stop there. We'll convert that input into a number, handle any mistakes the user might make, and compare it to our secret number. Then comes the fun part. We'll give instant feedback: too small, too big, or spot on. And of course, we won't let the game end after one guess. Nope. We'll add looping so the user can keep guessing until they win. Finally, we'll make sure the game handles invalid input gracefully, no crashes, just smooth, clean Rust magic. The goal for this video is to implement steps 2 and 3, prompting the user and capturing their input. But before we jump into the code, we need to cover a bit of theory to make sure everything makes sense. First, create a new project with cargo new guessing game. Then navigate into the folder using cd guessing game and open it in VS Code with code.command. Let's get coding. Awesome. Now let's extend into our src folder and open main file. It's time to talk about variables in Rust. In Rust, we use the let keyword to create variables. By default, variables are immutable, meaning once a value is assigned, it can't change. For example, this line creates a variable named apple and binds the value 5 to it. Rust automatically detects that the type of this variable is an integer based on the value provided. If we need to change the value of a variable later, we can simply add the mute keyword to tell Rust that we intend to modify it. We'll cover variables in more detail later in the course. This is just the minimal information you need to keep moving forward. Let's put our knowledge to the test and apply what we've learned. Let's start by declaring our first variable and call it apple. In Rust, we use the keyword let to declare variables. So let's create a variable called apple and assign the value 5 to it. In Rust, variables are immutable by default, meaning once we give the variable a value, the value won't change. We'll be discussing this concept in detail in the upcoming video. To make a variable mutable, we simply add mute before the variable name. This signals to Rust that we intend to change its value later on. Now that we know how to create variables, let's figure out how to print them to the console. We'll use the println macro. Inside its parentheses, we pass a string that includes curly brackets as placeholders, followed by the variable whose value will replace those placeholders. Now let's also print the updated value after modifying apple variable. Let's open the terminal and run our project using the command cargo run. We see our values before and after modification, confirming our variable update worked as expected. Now let's learn how to receive input from the user and use it in our application. First, we need to notify the user that we are expecting input. We can do this by displaying a message on the console using println macro. Now we need a place to store the user's input. Let's create a mutable variable called guess using letMute and initialize it with an empty string using string new. Our IDE notifies us that we've declared a variable that hasn't been used yet, and that's okay, we'll be using it in the next steps. Currently, we've displayed some text and created an empty variable. Now we need to add an I/O module to handle user input. We can do this using the keyword use. Now that we have the I/O module in scope, we can call stdin function to handle user input. This function returns a handle to the terminal standard input. Next, we call the read_line method on the standard input handle and pass guess as a parameter. This method takes whatever the user types and appends it to the empty guess string we provided. Since we want to modify guess, we pass it as a mutable reference using ~mute, allowing the method to update its contents. The ampersand symbol indicates that this argument is a reference, allowing multiple parts of the code to access the same data without making unnecessary copies. References are a key feature in Rust that help manage memory safely and efficiently. We'll dive deeper into borrowing and ownership in upcoming videos. Finally, readLine method returns a result enum, Rust's way of handling potential errors. Result type has two possible variants: OK, which indicates success and contains a value, and error, which indicates an error along with its error value. By using the expect method on result enum, we ensure that if an error occurs, the program will panic and display the provided message instead of failing silently. In our case, we chose to use fail to read line as our error message. Great. Let's clean up our code a bit and make it more readable. We can do this easily using cargo fnt, which automatically formats our code. Fantastic job! Now, this line of code grabs the user's input and stores it in our guess variable. But we're not stopping there. Let's bring it to life and see it in action by printing it to the screen. We'll use the println macro with a placeholder, just like we did before. It's time to run the code and see it in action. The program immediately prompts us to guess the number. Let's enter, for example, 5 and see what happens. You guessed 5. What a wonderful result. And that's a wrap for part 1 of our guessing game. If some parts felt confusing or a bit uncomfortable, that's 100% okay. We'll go through each concept in detail as we move forward. You did an amazing job. And hey, don't forget to smash that like button and subscribe so you don't miss out.